Hello everyone, good evening. Welcome back to Axelerant webinar series from Concept to Code. So this is the last episode of this webinar series where we discuss about the different phases of SDLC. We discussed about requirement gathering, grooming, estimation, and implementation phase in the previous episodes of this webinar series. And in today's webinar, we are going to discuss about the most important, crucial, and the scariest phase of SDLC, which is the deployment phase. To know more about a deployment phase, we have our presenter Kalaiselvan, technical program manager at Axelerant, with a decade of experience in Drupal and PHP. Let's welcome Kalai.
Hello everyone. Hi Tripti.
Hi, Kalai. So, Kalai, last episode of this webinar series, how are you feeling?
It's the most important episode and kind of funnier thing as well. We all have a lot of experiences to share with respect to this particular phase, and yeah, I'm looking forward to it.
One request, if you have not watched the previous webinars of this series, please do take a look at the previous videos. Kalai, I'm very excited to see the deployment phase and know more details about it. All the best for your webinar. Go ahead.
Thank you. Hello everyone. We are in this final phase, or is it really a finale, which is deployments, right? So yeah, let's go ahead. And okay, oops, looks like I missed one phase, or rather, I should say it is a part, which is peer reviews. So the reason I kind of striked off the phase here and made it as a part is it's not something that starts and ends with an entry or an exit criteria. Rather, it is something that needs to be done in every phase, and the peer review, when it happens in every phase, it saves a lot of time, effort, money for every stakeholder who are involved. We have a pyramid here right before us, and this pyramid kind of depicts what are all the various things that we need to check as part of peer reviews, starting with the correctness of the code, and whether whatever we have written is actually correct, and whether it satisfies the requirements and so on. And of course, that's the most important thing that we check, right? And that's why it's in the bottommost foundation of the pyramid, followed by secure, whether the code that we write is secure enough and it can handle malicious users as well, and whether it follows the coding standards and principles as outlined in whatever language and the framework that you are using. And of course, it's most important that it's readable as well, and that's the foundation, followed by writing elegant and inspirational code. The reason readability is coming before elegancy and inspirational is because we are mostly focused on writing, for example, reducing the number of lines of code to so that we can show how much we know, or how much shorter we can achieve something. However, it's more important that it is readable, first of all, for in irrespective of the experience of the person who's looking at the code. It's important that it's readable for them, and that is why readability is the most important aspect, even before achieving something in shorter lines of code, or showing your style in your coding. Of course, that also comes after readability, provided that whatever you write is readable in fact. So, and more than all of these aspects, the most important thing is inclusion. Inclusion in the sense that when you are doing peer reviews, you are using terms like we, us, and not pinpointing the developer who has been involved in the development of this particular change, or pinpoint to them like you have did this, and you avoid using the terms you as such. So it's very important that you use the inclusive terms so that it is a more collaborative discussion and you learn together as a team. And it applies to whatever aspect that you are trying to solve here. So there is another pyramid, yeah, and this pyramid talks about where you need to focus your energy on and where you need to automate the stuff. So let's go from the bottom, starting with the API semantics. And in the case of Drupal, this is very minimal, because most of the API is already written and you are just using or consuming that API. In all those cases, it's still important to ask whether you are using the right API, or you using it the right way, and following the standards in using those API as well. And however, for other languages, you can ask multiple questions like, is the API small as possible or large as needed? Or is there more than one way of doing things? Or am I assuming that this is the only way of doing things? And whether the API is good enough to handle all scenarios and things like that. And followed by implementation semantics. This is where we focus most of our efforts, and that is good, where we ask questions like, does it really satisfy the requirements? And this kind of maps to the correctness part in the previous pyramid. Is it logically correct? Is it performant? Can you observe this code using logging and everything? And also finally, is there any added dependencies or unnecessary complexities that you have added to the code? Followed by documentation. Yes, and documentation is part of peer review. And we have also made it some research changes even in our Jira workflow to have documentation after dev testing. Our earlier Jira workflow was dev testing, which is done by the developer, followed by peer reviews. Whereas now we have also introduced the documentation phase after development testing, so that the developer also updates the documentation for that particular task before handling it for review. And when the reviewer reviews, they do not review just the code, they review the documentation along with the code as well, and make sure that whatever changes is being done, that is being also updated in the documentation. Otherwise, we usually end up with outdated documentation, which doesn't help us at all. It completely defeats the purpose of documentation when it's outdated, right? So these are the three areas during peer reviews that you need to focus more on and spend your time and efforts, and manual efforts particularly. And the other areas where you need to automate are the test and the code styles. Here you need to automate these, because you should avoid doing manual testing. And also the coding styles is something that we have already automated using tools like PHPCS or PHPMD, and using our code quality checker, and for Drupal. And for other languages, we need to find ways of automating the code styles as well, even in your IDE during your pre-commit, or way before you commit, as part of pre-commit, and also in your CI/CD. So this pyramid is also, this is taken from our engineering handbook, so you can get the link from our engineering handbook and go deep dive into each of the questions that you need to ask yourself. This is not the questions that you are asking the reviewer, rather it is something that you are asking yourself to validate whether the code satisfies your the criteria explained here. And then you ask questions for the reviewer that will make them also think in the similar directions. So let's proceed further. And now we will come to the entry and exit criteria for the peer review. So this is, though I told like there might not be much entry and exit criteria. This is like the very basic minimal requirements for you to do review, which is like, if it's a code review, then it's important that the implementation is completed, and unit testing and approval of the positive cases by the developer, which is also needs to be automated, so that the developer need not ask the QA to do testing even before. So this will also allow the developer to do the testing before it's handed over formally to the QA, and the QA need not be involved in this case because it's automated. So the developer can run the automated test cases here, and they can test things by themselves, and mainly the positive test cases, and they can also ask for the peer review after that. So, and other work items, which you will see what are the other work items other than code, which you can ask for review in the future slides. The exit criteria really here is that you are in integrity with yourself, with the recommendations provided by the reviewer. So it's important that you align with the reviewer, that what is the intent or the perspective that they have behind the questions that they ask or the suggestions that they provide. And it's important you align with them on that. And we will also see what all you need to do and what you need to avoid during peer reviews. So the roles involved here are the mainly the developer, who is accountable for the code that they are doing, and of course they are accountable for getting the code peer reviewed, and they need to get support from the other team members, who can be QA or developer or PM and TL. And depending on the artifact that is being reviewed, different people play different roles here. So what can we do differently during peer reviews? So the first thing is to align on what needs to be reviewed. Usually we kind of think of peer review as code review, right? But it's not just you only can review code, you can also get peer review for implementation details, which is also very common that we do with the tech lead. And code review is done by the peer developers as well. And the requirements, you can also get review whether the requirements have been met, or if there is any scope creep, and this can be done by the QA or from the project manager. And you can also get reviews whether your estimates are right, and usually this is reviewed by the tech lead. And also you can get alternative perspectives and inputs on any other area across any phases, and this is where the peer reviews becomes very important. So it's important that you, once you do all these things, you flag the additional time needed for doing these additional reviews, and also with the relevant stakeholders, and also consider those in your future estimations. So that way you don't expect yourself spending unexpected time in reviews. Though it is good, it is also important that you learn from it, and also you kind of continuously improve in the next task that you do. It's important that you follow the guidelines in engineering handbook, as I told in the previous slide. And so you, whereas I would say code review is not really mandatory for every PR, and you are the best judge to decide whether you need a code review or not. And this is specific to code reviews. So because there might be small updates, like just updating a module, or updating a patch, and or even a bug fix, or even a very small bug fix which you are very obvious of. So it's important that you take a very decision on every PR whether it needs review or not. Usually in the case of module updates and those kind of things with respect to Drupal, we usually don't need to have a code review, because most of the testing is covered by the automation, and every PR need to not be reviewed by the tech lead. So first thing is that you need not review every change or PR, and the second is that it, even if you are getting it reviewed, it's not that every PR need to be reviewed only by the TL. It can be reviewed by your peer developers as well. And usually there is a question like, if I am involving developers who might not have the context about the code that I have changed, will they be able to kind of understand it? And that's the point. We need various perspectives here during a peer review, particularly with respect to code review, and that's when the peer review gets more effective. And it's important to look for these perspectives rather than seeking validation or the approval check mark as part of our peer reviews. So, and learn from these perspectives as well. So what is the significance of peer reviews? So quality reviews, both code and non-code reviews, helps us identify bugs, potential issues and gaps much earlier, when the cost of fixing them is much less than fixing them post-production. Even sometimes you get to find issues even before it is handed over to the QA, right? So in that cases, you are even kind of reducing the QA effort involved in your project, and the number of reopens done by the QA as well. So yeah, now we discussed about peer reviews. Let's go into the deployments. So the entry criteria for deployments is, of course, the completion of previous phases and the QA approval, the internal approval that it is ready for production, and after which we usually give it for user acceptance testing, and followed by fixes done for the user and UAT, and the approval from the customer that their side testing is also done. However, there might be some cases where you need to get customer approvals on the deployment date or time, and yeah, all these things are the entry criteria for deployments. So the exit criteria for deployments is what deployment to production, right? But it doesn't end there. It's important that you see whether the changes that you actually wanted to see on production is available, and whether the sanity and regression checklist, mostly automated, is also passed. And finally, the whether the post deployment monitoring needs to be done based on the size of your deployment. If you have deployed a very large number of tickets, it's important that you monitor it at least for some period of time, larger than for smaller deployments. So I want to ask a very important question here, which is your team self-sufficient, particularly for deployments? So because if you think if there is more to the entry criteria than what is listed here, for example, availability of specific roles like the QA or the TL or the developer or PM or any team member, and even including an SRE needs to be available for the deployment. Or even sometimes we might need a particular client stakeholder available even before you deploy the things. Getting approval is a different thing. However, having a requirement of a particular client stakeholder being online before the deployment, even after getting an approval, is a different thing. So if these things resonates with you, it's important that you reassess if you have automated enough and if you have documented enough. And this needs to be done on both the sides, both on the client side and both on our side, majorly on our side. So it's important that you empower your team so that there is no single person dependency to do a deployment. And this is very crucial for any team for able to do deployments anytime, because deployments can be unexpected as well, right? And you need to be able to do it as it demands. So the roles involved in deployments are again majorly the developer, followed by the other roles who are more in a consultative way or in a pull basis. So the developer needs to take care that they deploy the things that they change to production, followed by getting help, but less involved compared to peer reviews. In the peer reviews, they play a more supportive role where the other team members are more involved providing their inputs. Whereas in the case of the deployment, they are playing a more little that not so involved role as peer reviews, where they are involved only on a pull basis. So what can we do differently in deployments? So the first thing, like we discussed so far, the most important thing is avoiding dependencies, any kind of dependencies, team member dependencies or tool dependencies or anything like that. So deployment is not one big event. So and if that is the case, then there is definitely room for improvements. And it's important that you deploy as frequent as possible, with the deployment window being as minimal as possible. And also leverage automation for repetitive tasks, including QA, and even in the case of deployment and in CI/CD pipelines. And it's important that you also gather client feedback post your deployment. We usually get NPS feedback, but this is more focused on how did we do this particular deployment, and whether how did they observe the tickets being deployed to production, where everything as they expected, or did they see anything unexpected in production for this deployment and things like that. So apart from that, it's important that you do monitoring of after the deployment as well, based on the size like we discussed earlier. So what is the significance of this phase? The significance of this phase is that you reap the fruits of your hard work, right? You finally get to see all the hard work that we have spent so far in production being used by our end clients. And there can be two types of teams here, like we discussed. So the most common team where deployment is an large event and everyone is focused on doing it right. And we even allocate specific days for deployment, and we are more focused on that for the entire day, and we avoid even working on other tickets because we have a lot of things to do on that particular day. And there is also self-sufficient team where deployment is like any other event in the project. Like you work on any task, deployment is like any other task. And it's important that you reflect on these questions, and I would leave you with these questions, which is like, what is the kind of team that you currently work in, and what you can do to moving from being any other common team where deployment is a large event and everyone is focused on getting it right, to being a self-sufficient team where deployment doesn't put that much pressure on any team member, or it's not something that we are scared of. So it's important that you reflect on these questions and see what action items you can take in order to make deployments more easier for everyone, including the client, and so that it's not one major big event that we are doing once in a while.
Thank you, Kalai. Thank you for doing this webinar series on SDLC, and really appreciate all the efforts that you have put in for this webinar series. Thank you, everyone, for joining today's webinar. If you have any questions or want to reach out to Kalai, please do reach out to them on the shared LinkedIn URL. And we will be soon back with yet another webinar series. Until then, take care. Bye bye. See you.